So this is OrCAD X Presto, our brand new layout user interface. And I'm going to give you a quick flyby of the user interface and some of the capabilities. So the user interface is based upon most modern applications where you're going to have three main panels on top of your design canvas. So this panel over here controls the visibility. This gives you access to control visibility to, for example, turn on and off layers, entire layers at a time, turn on and off all types of objects. For example, you can turn on and off shapes. You can turn on and off text, pins, vias, objects. You can also, if you want to, turn on additional layers in here. For example, let's say you're doing some sort of flex design or you really need to see your solder mask. You can turn on and off the mask layers to control the visibility of those. Or if you want to additionally see and turn on and off things like keepouts and package keepouts or constraint regions, you can turn those on and add those to the matrix as well. Gives you quick ability to turn on and off the design outline, and then different categories for commonly grouped things that you need to work with at any given time. For example, your manufacturing layers, your rigid flex, your surface finishes, your custom data layers, and you can add things to these layers to configure yourself. You'll notice that as I'm working with these things here, this floating layer toolbar also adjusts. So all of these panels, this visibility panel, this property panel, this search panel, all of these things can be tagged and pinned to give you more real estate in the design. So once you get everything set up, you may not always have these active. You can also undock these and peel these off to another monitor if you have a second monitor. In normal operation mode, you may have this visibility panel pinned, and then you can use this floating toolbar here to turn on and off layers or objects on a particular layer. In addition to giving you visibility for the conductor layers, we've also given you a matrix to control the visibility for your components. Often as a designer, you need to quickly turn on and off conductor layers, but you also need to quickly turn on and off components. So here we give you a quick view that lets you quickly turn on and off all the components on the top or the bottom. That gives you a nice dynamic reference designator display. So as you zoom into different levels, you can see the different reference designators at different degrees. Or you could say, instead of this dynamic reference designators, I want to actually see my silkscreen reference designators or my assembly reference designators. So that's the visibility panel. You also get a net navigation panel where you can see all of your nets grouped hierarchically by groups, buses, match groups, etc. You can navigate those nets from the visibility panel, and that's going to take you to and zoom you into that area on the canvas. And that is also going to select that net and show you the properties of that net in the properties panel. So all of these panels, visibility, navigation, search properties, they're all dynamically connected. So you can start in any one panel and use that as a way to see properties or to navigate to other information in the design. For example, here I've selected this net. You're getting the information about that net, which you can then manipulate. You can change it to a power. You can modify it as a diff pair. And then you get these blue hyperlinks that then you can then use to populate the search panel. For example, total connections, 8 total connections. You can select that. And then now this search panel allows you to navigate and find those connections in the design. If you have nothing selected, the properties panel gives you a top-level properties view of the entire design, which I'm going to come back and overview in a second. Finally, you have the display panel. This allows you to control general display information, like, for example, if you want to see net labels on traces, pins, what your temp highlight's going to be. And this is where you can switch back and forth from 2D to 3D. Notice that in the 3D view, the user interface is exactly the same as it is in the 2D view. So for example, in the 3D view, if you were to select a component, you will then get its component properties over here that you can look at. And then again, you can navigate from that component property panel to find and navigate the other components that have the same information. Also in the 2D view, you get the same net navigator. So if you want to look at and navigate nets in 3D, you can do that. While you're navigating 3D, you may say that you want to also adjust the visibility of the symbols. For example, you may want to hide your mechanical bodies, or you may want to hide the extruded place bound, or you may want to go into the visibility and start turning off dielectric visibility so you can really start to dial in and see the conductor layers as they're being displayed. Or you may want to go into visibility and adjust the flex bends and how those things are being bent in the design, which is going to come into play later on when I talk about the 3D DRC. And again, you also have the same floating visibility panel over here. So that's the visibility panel. Now let's take a look at this properties panel. Again, at the top level, as soon as you open your design, we give you all the relevant information that you probably want to know about your design. You have a selection filter over here, which you can use if you really need to control what you select. You get a design status, how many unplaced components, unrouted nets, and unrouted connections. Again, that can be used as a navigation ability here, so you can use this and then you can start to navigate your unrouted nets. As a property over here, you can then say that you want to see or not see the rat's nest for your unrouted nets, or you can also do that from this visibility panel over here to turn on and off the unrouted nets, or you can show and hide all of them individually or collectively. You also get access to quick top-level reports. For example, as a designer, you're going to probably always want to know, do I have shape islands, or do I have shapes that are out of date? Those things also are going to populate a navigatable list panel down here that you can use to also operate on these shape islands. Maybe you want to delete them at this current time, or you want to assign them to an existing net. You also get a DRC browser. So one of the advantages of the OrCAD X platform is we have a leading DRC engine. The DRCs can be online all the time, or you can disable some of them depending on what you want to see while you're working. And this DRC pie chart is going to tell you how many of what type of DRCs you have. You can then navigate this DRC pie chart. For example, let's say you could go into the electrical DRCs. You can then see what type of electrical DRCs by category. This may break down into sub further categories. And then notice that this DRC chart down here, this search panel down here, is now your DRC navigator. So if you want to go into your spacing DRCs, you could then navigate your spacing DRCs, and then here you could say that you may want to wave them. So you can see how these panels are all interacting nicely with each other. All right, to go back to the top level design canvas, then again, this is where you can look at your DRC errors, shorting errors, wave, check out your design parameters, and finally top level design attributes. Let's go back to the visibility, and I'm going to turn off some of these internal layers here. Selecting a component, you get nice component information. You can also see if the component's in sync with your library with respect to status. And then notice that you also have the ability to manipulate selected objects from the canvas. So for example, if you were to select multiple components, you then have your ability to arrange them, mirror them, align them. So it's not only a selection option, it's the ability to manipulate options. If you were to select a trace segment or an unlocked trace, you can unlock the trace and manipulate its location in the design. For example, this net here would allow you to manipulate its properties. Looking at an individual pin, you get information about the pad stack information. It's a through-hole pin, its diameter, its finish diameter, its aspect ratio. You can even manipulate the thermal reliefs at a pin level if you need to, or at a shape level, or at a global design level. And then you can even see what pad stacks it uses, which again is going to populate the search panel with all the pad stacks in the design. You can also use this search table anytime. If you have nothing selected, the search table represents every single database object in the design, grouped by components, nets, pins, traces, shapes, etc. And you can use this search table to find very specific collections of data that you want in your design. For example, let's say you want to find a particular footprint that starts with MTG. You can find and filter by that. or you can say, I want to filter by every footprint that's on layer top. You can do that. And then you could find every footprint on layer top that's at a certain XY location. And you can do wildcard searches, equal to, greater than, less than, or filter by specific data values. So using these complex searches, you can find any specific thing you're looking for in the design by grouping, and then use that to work from the search table to find something, or you can use the search table in collaboration with one of the design commands. So for example, one of the greatest things you could do is find all the same parts and then run the fan out command on all those same parts to fan them all out at the exact same time. Also up here, you have access to your grids where you can quickly turn on and off the grid or change the grid to any particular out of the box value in mils, millimeters, or microns, or you can type in your own particular grid value if you want a grid value. And then also finally, you have the snapping. Snapping controls what the snapping is when you pick an object up and when you put an object down. So for example, let me turn back off the component data. I don't want to see all that stuff, but maybe I do want to just see the top layers. If you were to zoom in here and pick up this component by clicking right here and going to the move command, it's going to move. Let me unlock that part. There we go. It's going to move that part based upon where I picked it up by that pin. And then as I move it around, it's going to snap to the other pins or the vertices or the midpoints. If you're to drop the part and pick it up from the middle, you're now moving it from the middle, and it's going to snap that middle point to the endpoints or the vertices. So snapping works intelligently on pickup, endpoint, put down. You don't constantly have to be telling the tool what you want to snap to. From a capability perspective, the tool gives you all the capabilities you would need as a designer. And I'm going to walk through the toolbar here real quick to give you an example of everything you have access to. You have access to a general placement commands. You have access to place replicate, circuit replicate, renumber reference designators, swapping. You have access to slide command, delay tune, phase tune. When you select a command, you're going to get a floating command window. And this is one of the other examples that we've done with ease of use. Here you can see this command window that gives you a dynamic display showing you exactly what you see is what you're going to get with respect to what these parameters are and how you can manipulate them in the design. And then, of course, once you get the tuning pattern that you want, you can then apply that tuning pattern to a net in the design. So you have access to delay tune, phase tune. Then you have access to your basic add connect command. The add connect command works in a manual mode or an assisted mode. And while you're running add connect, you may need to manipulate your command parameters. You can hit the X key on your keyboard to hide those command parameters if you don't want to see them while you're working. And then hitting X again is going to summon those commands right to your cursor so you can change the command parameters back and forth without doing any mouse travel away from where you're operating on the design. You also have access to fan out commands. You can do radial based fan outs where you can set the direction of the radial. You can do linear in, out, again with the nice heads up display showing you what you see is what you're going to get. A lot of these commands, for example, are constraint driven. So here the width of the traces are going to be driven by the constraints. If I were to go back into the add connect command, notice the trace width can also be driven by constraints. So OrCAD X, one of the key advantages that we'll talk about later, is all the constraints that you can use to drive all these commands, which again is going to determine your signal and power integrity, manufacturability, and all those things. You have access to draw shapes, add voids, shape utilities like merge, Boolean, trim corners, via structures, via arrays, lot of different types of via arrays that you can put all over the board, adding text, adding test points, adding lines, adding test points. So the simple UI should not dissuade you that it's not fully capable. This has all the capabilities of enterprise PCB design tools. So let's show you some more of these things in action. Let's look at design review. So if you launch design review, you're going to get a design review panel over here. So you still have access to all your properties, and now you can work on design review. Design review works by allowing you to add different comments to the design. So I'll add a comment and I'll say, @Dan, move this connector, or MCAD. You can choose to draw boxes or arrows. For this example, I'll draw a box around this connector and I'll submit it. Then I'll zoom in over here, turn on my ground layer, add a new comment. And in this case, I'm going to choose to add a pointer arrow, right? So you can add as many comments as you want into the design, and then anybody else that can open the design can come in, open up the design review and markup, and they can choose to turn on and off the markups. They can then navigate through the markups to work through them in the design. So let's say you open the design and you're zoomed into this area. You could select this markup layer and it's going to take you to that markup, or you could take this one, it's going to take you to that markup. You also have the ability to keep your existing layer visibility if you want. So this one here, you can see it's going to turn on that ground layer. Maybe you don't want that to happen, so you can do that, and then it will no longer turn on those layers if you want. You also have the ability to see a picture of what the design looked like at the time the markup was created. So if you want to see like a before and after case. This design review and markup is a part of the design database. So now anybody working on the design can now participate in design review and markup. Another capability I want to show you is the ability to make and create PCB footprints. So not only do you have a new layout editor with OrCAD X Presto, you have a new footprint editor with OrCAD X Presto that works exactly the same with the same UI. Notice here I've opened a footprint, and now you get top-level footprint properties. This is all the data you'd probably want to see at a glance when you open a design. How many electrical pins, how many surface mount pins, mechanical pins, extents, is it based on the place bound or a mechanical body? Do I have a mechanical 3D model associated with it? What's my origin? How many pad stacks? Which pad stacks? Do I want to refresh them? Do I want to replace them? Change log. Same as before, these things are navigatable windows. So for example, if you say, well, where are these mechanical pins? Let me find them. You can use that to select the search table and then navigate those through the design. From a perspective of creating and drawing a footprint, one of the most common things you need to do when you create a footprint is create a new pad stack. So we've given you a pad stack wizard that allows you to create the most common typically used pad stacks in the design. You get a whole family of surface mount pad stacks that you can parametrically create. So you can modify the height, width, solder mask expansion, paste mask expansion. Set those parameters in, save, add the pin. It creates the pad stack, and now you're automatically in the add pin mode where you can say this is going to be electrical pin, mechanical pin. I want it to be a single pin or an array. Is that array rectangular or polar? Okay, and then you can just add those pins into the design. In addition to surface mount pins, you also get through-hole pins where you can create a through-hole circle, over circle, or a slot, and then you can say this is a plated or a non-plated through-hole pin. Or if you know you already have that pin somewhere in your library, we give you a nice pad stack search capability where we give you a list of all the pads that are in your design. And then as you select those pads, you can see all the parameters of that pad from your library. For example, here it shows you that it's a circle, diameter, annular ring, has a solder mask pad that's different on every layer. That's why you're getting those triple dots in there, or if it's another through-hole pin, you can see all of its information. So this allows you to find the pin that you want, and if that's what you want, you double-click it, and then that pin is attached to your cursor, and you can add it in. Finally, if you want to draw shapes in the pad stack editor, if you want to draw a shape, we'll give you a nice drawing shape mode where while you're drawing a shape, you get on-screen heads-up display of the length and the angle while you're drawing this, and you get nice snapping showing you like, oh, that's the snap point of that vertice. This angle is going to be the same as other angles in the design, and you can easily switch from drawing an arc, drawing a half-point arc, to drawing a full arc with the radius and the angle while you're drawing a footprint. So let me open up another design database here. And now I'm going to show you one of the more powerful capabilities that we've introduced. I already showed you the 3D canvas, but what we also give you the access to now is an online 3D DRC that's checking against the 3D models in the design. So for example, here you can see in this design database, it's telling you I have different three-dimensional DRCs. If I were to zoom in here, you can see that there's one right there. That LED is conflicting with something mechanical. Not sure what that may be, but you have a mechanical DRC. And if you were to go into move mode, and let's say I'm just going to grab this part and move it over a little bit and drop it, I got another 3D DRC. So the point I'm trying to make here is you don't have to be seeing your 3D mechanical enclosure to know that you violated a 3D DRC. If I were to look at this in 3D and look at this from the top side view, this is why you're getting those 3D DRCs. You have this mechanical enclosure with those cutouts for the LEDs, and anytime you move those LEDs around in 2D or 3D, it'll be telling you that you have a DRC in 3D. And again, you can use this DRC navigator to navigate your 3D DRCs in your design. Or if you have a 3D DRC, you can select a couple of components in 3D, and then you can use the align capabilities to clean those things up. So that's super powerful because now you can actually have your 3D models for both your board components and your mechanical enclosures. And while you're doing placement in 2D or 3D, you can get your 3D DRCs live. So that way you're not having to place a bunch of parts in 2D, switch to 3D, run a DRC. It's all live. Another thing while I'm in here that I want to show you is your user preferences. We are going to give you configurable shortcut keys for all of your display, comment interface, layout display. So for example, instead of using the menus to switch to 2D and 3D, you can assign a shortcut key. The views in 3D, you can assign a shortcut key. Launching commands, you can assign a shortcut key. Inside of a command, you can have shortcut keys to do things like add a via, route from target, toggle, turn your grids on and off. Again, that's one of the things that's out of the box, easy to use. Another thing I want to talk about is flex and rigid flex. The design tool fully supports flex and rigid flex. And one of the most common things you need to do when you're dealing with rigid flex is set up your zones and bend areas. A zone would be an area like this here where it's going to be a different stack up. A bend area is something like this that dictates where the flex area is going to bend. So when you select your design outline, you can see how many different zones you have in your design, and you can navigate these different zones to see where they're at. And while you're selecting them, you can see which particular stack up corresponds to that particular zone. So you would go into your stack up editor, make different stack ups, and then you can assign those stack ups to different areas in the design. Selecting the design outline again, you can also use that to navigate your bends. So here you have a bend area there, a bend area there, and then these bend lines are going to dictate which order it gets bent in. Is it bending up? Is it bending down? What's the radius of the bend? And when you add a bend, you can put in a via keep out or a route keep out. Adding these things is very straightforward. Under the setup menu, you can go under flex and choose to create a zone, or you can create a bend. Creating a zone, you can draw a polygon or a rectangle, and you pretty well just have to draw a rectangle around the area of the design. It's going to snap that to the board outline, and then you just specify what stack up that particular zone has. If you need to create a bend, you can choose to create bend. Notice in the top right-hand corner, this is another example of another ease of use capability that we have a quick help window for new users that you can turn on and off, that in some cases where commands may not be super intuitive to what you need to do, it's going to guide you to what you need to do. So for example, it's telling you to click once to start a bend line. So now I'm drawing a bend line. I've finished drawing the bend line, and then you can manipulate the parameters of the bend line and add those in. Note that if you are using defining those things from your manufacturing tool or from your mechanical tool, if you import something from IDX or from MCAD X, you can have all those zones and bend defined by your mechanical and then import those in to OrCAD X. Let me turn on my shapes on the top layer now and show you some other shape manipulation capabilities. OrCAD X supports dynamic intelligent shapes. So when you draw a shape, the shape's going to be dynamic. It's automatically going to plow and heal and void based upon things. And from the shape parameters, you can specify how that shape's going to behave. You can specify its priority. So if you have multiple shapes on top of each other, you can specify which one gets filled first and which one gets filled last. You can specify which net it's attached to. It tells you the area of the shape. It tells you if that shape has any islands or any floating copper. Here you can specify the shape fill. You can specify it solid, or if this is something that's going to be in a bend area, you typically want to select that as a crosshatch, and you can specify what type of crosshatch pattern you want to have it have. These things are parametric, so all these things you could type in these numbers here, and these are going to manipulate and change the primary gap, primary width and spacing, and the minor gap and spacing. I'm going to set that back to solid. You can specify the corner style. You can specify the minimum web. You can also specify the thermal relief for every pin. Maybe you want all the thermal reliefs to be orthogonal or full contact or 8-way connect. Or you can specify different types of thermal relief connections for SMD pins, through-hole pins, and vias. And while you're working with that, the thermal relief connections are going to update in the design canvas, so you can see as you manipulate these parameters, what you get in the layout is going to be what you set in the parameters. And then, of course, adding a dynamic shape is super easy. If you want to add a dynamic shape, you can choose to add shape. You can say what type of shape it's going to be. You want to add a conductor. You want it to be on the top layer. You can pick your net, and then you could draw in your conductor on the top layer. And then you get a brand new dynamic shape, and then you can select that shape and manipulate its properties like I just showed you. Okay. So let me show you one of the other capabilities that we've added into OrCAD X layout, and that is manufacturing and assembly data. So you're done with your design, you need to create your fabrication and assembly drawings. Another new capability inside of OrCAD X is LiveDOC. LiveDOC is a template-driven fabrication and assembly drawing tool. So when you first launch LiveDOC, it's going to automatically create all these views and charts based upon a template that you can create. Out of the box, we give you a 2-page template that gives you top view, bottom view, cross-section chart, cross-section table, and then assembly views on the second page. If you want to create more pages than your template, you can choose to add a page. once you add any page or on any of the existing pages, you can add in any of these drawings and charts that are, some of them are out of the box drawings and charts that are always going to be there. Or for example, these artwork layers are based upon the artworks that you have defined or set up for your design. So you could add in a top layer, a ground layer, and then you could come down here and add in a drill chart. So all of these views and drawings and charts operate the same way as the layout editor. For example, selecting this view, you get the properties of this view over here where you can change its scale, say whether you're looking at it from the top to bottom, or change its rotation. If you select the drill chart, you can specify whether you want the primary units to be in centimeters, secondary units, sort the hole size. Maybe you don't want to see these columns at all. And then you can also set these things as a default. So anytime you add a new drill chart or symbol or table, that's going to be the default in the design. These views can also be customized. So if I were to select this view and go into visibility, you now have the same visibility controls as you do in the design. And maybe in this view, you want to see all the traces. So it's now going to update that view to show the traces in the design. These are not just pictures. These are actually live viewports into the layout design, which is why we call it LiveDOC. So let me show you an example of that. First, I'm going to add some dimensions to the tool. So I'm going to go into linear dimensioning toolbar. I'm going to select linear dimensions, select the first point, and then you can say which axis where you want those dimensions to be placed. I'll place those right there. Select ordinal dimensions, pick this first point, specify where I want these ordinal dimensions to come out to. I want them to come out on this side. And then I'll just pick a couple other points here. And then I've got the ordinal dimensions. Like everything else, you can select the dimension properties. And then here you can specify whether or not you want to display secondary units, what you want those secondary units to be displayed in, if you want leading zeros, trailing zeros. And you can even customize the text to put in your own words on top of the dimensions that are specified as primary and secondary. So the dimensions are going to be the same, and then you can put text before or after, above or below them. Also, you can change the fonts, the color, everything you want. So now that I've added dimensions in the design, your fabrication and assembly drawings are done. That's how you want them to be produced. If the design data changes, for example, let's say if this mounting hole got moved over, I'm going to move it over a lot just to visually show you how this is going to look. That mounting hole gets moved over. You go back to LiveDOC, and LiveDOC is going to update. Every single view that had that mounting hole in it is going to be updated, and any dimensions associated to that mounting hole are going to be changed. If you were to add mounting holes or holes in your design that adds more holes, your drill charts would be updated. So LiveDOC is live, always up to date. Once you get LiveDOC designed the way you want, you can save it as a template. And then back in OrCAD X layout, you can specify what template you want to use. And then you can throw any design at that template. All the drawings, charts, and tables will be automatically generated. Then all you need to do is add your dimensions and your specific fab and assembly notes, and then you're off to the races. Once you get your LiveDOC finished, you can then go under manufacturing and choose export to manufacturing. This is now a one-shot and done ability to create and generate all the manufacturing and assembly data you need for your design. It's broken down into different categories. So here you have your fabrication IPC 2581. If you want to generate that, you would check it. And then these subcategories, you can check them and can configure that particular report or drawing or data. So if this is what you want to have in your fabrication view PDF, you can configure that. If you also want to generate artwork, you would check this category, and then it's going to generate all these artwork layers. And then you can also configure things like your NC drill report, your back drill report, fabrication view PDFs. You can also generate ODB++, And then you get into your assembly data. What assembly artworks do you want to generate? Do you want to generate a Fab Master extract? Do you want to generate assembly view PDFs? Do you want to generate a test point PDF? And then you have design reports that you can generate if you want to generate those as well. And then, of course, LiveDOC, fabrication assembly drawing, it's going to go into the LiveDOC that you have generated and create a PDF of the LiveDOC. So everything that you have checked here, it's going to go through and generate all that data, create a single file archive in your working directory. If you want to customize and configure this, you can start to create your own views in here. So you can collect and assemble your own types of reports, artworks, images, whatever you want to create and configure. So if there's something or a collection of data that you're always generating, you can start to create your own set of data here. Everything in this form is going to get saved. So once you set it up once, you generate it. The next time you come into this form, it's going to have the default settings that you set the last time. So that's going to super speed up your ability to create fabrication and assembly drawings. So in summary, OrCAD X layout, brand new user interface built from the ground up. It falls in line with user interfaces common in almost all applications nowadays, where you have visibility controls, navigation controls, search controls, properties, all the design capabilities you need for a professional layout tool, dynamic review and markup, single shot manufacturing. I didn't even touch on the constraint manager, which is leading edge constraint manager, access to reports, access to flex. So that concludes the demo. That's everything I wanted to show you today. I kind of just wanted to give you a quick flyby of the new tool, how it looks, how it operates. Hopefully you saw some things that you're interested in and you'll want to come back for more.